This is the video for 5.2 and we are talking about direct variations. You did learn about direct variations last year, so a lot of this should sound familiar. And remember, I am switching the order of lessons 2 and 3 in this chapter. But what is a direct variation? A direct variation is a relationship that can be represented by a function in the form y equals kx. So this is an example of a direct variation with a positive slope, and this is a direct variation with a negative slope. But what do they both have in common? They are both straight lines that go through the origin. So a direct variation is a straight line that goes through the origin. In other words, a direct variation is a straight line that has a y-intercept of 0. So think back to yesterday when we talked about y equals mx plus b. Whenever you have y equals mx plus b and your b is 0, your y-intercept is 0, what you have is a direct variation equation, and we call that y equals kx. So we also talked about a parent function yesterday. The parent function of a straight line, which is the simplest form of a straight line, is y equals x. And so y equals x is a direct variation, and it's a direct variation that has a slope of 1. Okay, so now let's talk about what the constant of variation is. The constant of variation is also called the constant of proportionality, and that is the k. That is also going to be your slope. So let's look at example number 1, identifying a direct variation. So I said a direct variation equation is in the form of y equals kx. So in order to identify if an equation is a direct variation or not, you have to solve for y. And then you look at the equation and then you compare it to y equals kx. And you say, is it in the form of a direct variation? So let's look at this example, 7y equals 2x, and solve for y. So if I wanted to solve for y, what would I do? I would divide both sides by 7, and this is what I would get. And so I have to look at it, and I have to compare it to the direct variation equation, which is y equals kx, and I have to ask myself, is this in the form of a direct variation? And yes it is. So this is a direct variation, and the constant of variation is 2 over 7. But now let's look at this equation. Again, I'm trying to identify if this is a direct variation, and so I want to solve for y. So how do I solve for y? What do? I want to circle out the term that has the variable I'm trying to solve for, and I want to deal with that last. So I want to get everything away from y, and so where do I start? I start by subtracting 4x from both sides, and this is what I get. Now notice, I put the term that has the x variable in it first because that's appropriate form. Remember from yesterday. Now what do? I want to divide everything by 3. I want to divide every term by 3. And once I do so, that's what I get. And so is this a direct variation? And the answer is no, it's not. Because remember, a direct variation is plus 0. This is not plus 0. This is plus 8 over 3. So this is a straight line, but it has a y-intercept of 8 over 3, not 0. So this is not a direct variation. Okay, so go ahead and hit pause and work out this on your own and determine, is this equation a direct variation? And if it is, what is the constant of variation? And so here's your answer. y equals negative 4 over 5 times x. Yes, it is a direct variation, and the constant of variation is negative 4 over 5. Okay, let's look at example number 2, writing a direct variation equation. Suppose y varies directly with x and y equals 35 when x equals 5. What direct variation relates x and y, and what is the value of y when x equals 9? Okay, let's start at the beginning, and what is it telling us? What do we know? It says suppose y varies directly with x. So what does that mean? We know we have a direct variation equation. So what else do we know? We know that y equals 35 when x equals 5. So what's my constant of variation? My constant of variation is 7. So what's the equation that relates these two variables? Y equals 7 times x. In other words, what this is saying is I multiply x by 7 in order to get to y. So now let's answer the question. What is the value of y when x equals 9? 63. So go ahead and hit pause, rewind that, watch it again if you need to, and then try the on your own problem. Okay, so it says suppose y varies directly with x. So what do I know? I know it's a direct variation. What else do I know? When x is negative 2, y is 10. And so then what's my constant of variation? And so then what's the equation? And so what is this equation saying? I multiply x by negative 5 in order to get to y. So then what is y when x is negative 15? And the answer is 75. If you got that wrong, pause the video, make sure you understand what I did, and rework it. Okay, example number 3, writing a direct variation from a table. Does y vary directly with x, and if so, what is the direct variation equation? So look right here, and I said remember, the direct variation equation is y equals kx. Well, what happens when you solve for k? K equals y divided by x. So first, pause the video and make sure that you understand this relationship. If y equals kx, then k equals y divided by x. So if we want to determine if the relationship between x and y is a direct variation, all we have to do is take y divided by x. Once I take y divided by x each time, I get the same number. I get 1.5. And so what does that tell me? That tells me, yes, y does vary directly with x. This is a direct variation relationship. I can create a direct variation equation, and the constant of variation is 1.5. So the equation is y equals 1.5x. Because what is this telling me? It tells me I want to multiply x by 1.5 each time in order to get to y. 4 times 1.5 is 6. 8 times 1.5 is 12. 10 times 1.5 is 15. There is a direct variation. Y varies directly with x. So in other words, this is a straight line. Here's the slope, and it goes through the origin. It has a y-intercept of 0. But now let's compare that to this. Is this a direct variation? When I take y divided by x, do I see the same number? Is there a constant of variation? And the answer is no. If I take y divided by x here, I get negative 1.6. But if I take y divided by x here, I get 2.4. So this is not a direct variation. This is not an equation that's in the form of y equals kx. Now this is a straight line, and so we could do what we did yesterday and create an equation from this graph. We can take any 2 points and we can figure out the slope, and then we can plug one of the coordinates in and determine b, and we can create a y equals mx plus b equation. But because b is not 0, this is not a direct variation. Okay, so go ahead and pause the video, do the on your own, determine, is there a direct variation, and if so, what is it, and what's the equation that describes this situation? And so the answer is yes. The constant of variation is negative 0.75, and here's the direct variation equation. Okay, and finally, let's review. I did say that there's a lot you have to memorize in this chapter, and I said go ahead and start making note cards now and start learning the material as you go along. So when you sit down for your assessment, it's not quite as overwhelming. So the first note card I said you need to make is a note card to quiz yourself on what is slope. What is the equation for slope? And the answer is y2 minus y1 over x2 minus x1. So the other side of this note card should say, what is the slope formula? And this is just a good way for you to study as you go along and to quiz yourself. Okay, your next note card should say, what is slope-intercept form? And when you flip that around, it should say y equals mx plus b. And finally, let's add to your stack of note cards here. What is the equation for a direct variation? And once you flip that around, it should say y equals kx. And the reason why I'm showing you this is because I just want to show you what you need to do to study this as you go along. Create note cards with a question on one side and then the answer on the other. And every day, just flip through them.